Let's look at the first of the three questions we can talk about when it comes to span. So this is when you're given a vector and asked, is this vector in the span of some set? So first off, let's look at this idea. What does it mean for B to be in the span of S? This exactly means that B can be written as a linear combination of elements of S. Okay, so that means, in more sort of mathematical notation, that the equation C1V1 plus CK equals B has a solution. So being able to solve this equation means being able to write B as a linear combination of the VI's. So that's what we need to do. Okay, so let's look at an example. Suppose we're asked, is the vector 2, 2, 1 in the span of the two vectors? We'll take V1 to be 4, 0, 2, and V2 to be the vector 1, minus 1, 1. Okay, so here's our set S. S has two vectors in it, so S is the set of V1 and V2. And we're being asked if B is in the span of those vectors. So this equation, C1 V1 plus C2 V2 equals B, that's the thing. We're trying to determine whether or not there's a solution to this equation. So in other words, can we find a C1 and a C2 to solve this equation right here? So in terms of the numbers that we've got for this problem, that means we're looking to solve C1 times 4, 0, 2 plus C2 times 1 minus 1, 1 equals 2, 2, 1. And we know from matrix multiplication that a linear combination of columns like that, that's the same thing as a matrix product. So this is the same thing as 4, 0, 2, 1 minus 1, 1 times C1, C2 equals 2, 2, 1. So the question of whether or not we can find a linear combination is the question of whether or not this linear system is consistent. Okay, so how do we determine if a linear system is consistent? Well, we set it up as an augmented matrix and row reduce. So we'll take 4, 0, 2, 1 minus 1, 1, and augment with 2, 2, 1. And we row reduce. And so let's see, so I can swap the bottom one to the top and subtract it from the one that I just swapped. Middle row will stay the same here. So if I subtract that 2, 1, 1 from 4, 1, 2, it's going to look like 0 minus 1, 0. And you can already probably see that this is inconsistent, but just to make it completely clear, I'll do one more row operation, well, one more set of row operations. And there we have the hallmark indicator of an inconsistent system. We have zeros to the left and a non-zero to the right. So we know it's inconsistent. And so since inconsistent means that the system has no solution, that means we cannot find a C1 and C2. So that means that B is not an element of the span of V1 and V2. So our answer for this one is No. Now, if, yeah, so we'll continue looking at this example in the next clip.